Example 6.4 is asking us to find the equation of the tangent to the function from an external point for -10. Because this is our first go at this type of question, I'm actually going to show you the graph of what the answer looks like. So the purple one is our function, y equals 5x squared minus x minus 6. And down here you can see our external point, which is for -10. It's quite a compressed scale, which is why it looks like it's sitting just below the x-axis, but this is our point. Really what we're doing is we're getting our ruler and we're lining it up on our external point, which is down here, and we're moving the ruler while it's still on that external point until it just touches the curve, and that's the tangent that we end up with. And we're going to calculate what the point of contact is and what the tangent is. Same on this side, recognizing that because it's a curve, any external point is very likely to have 2 points of contact, thereby creating 2 tangents. You can see this is the second tangent that goes through our point of interest and touches the curve at a second point. So that's really what we're doing here. We've well and truly moved on from doing this graphically, so it must be done algebraically. All right, so the first thing we need to calculate is the point of contact between the tangent or the tangents and the curve. We don't know where the tangent is going to touch the curve, so we just let it equal some unknown value of a, and then y, we sub in a for x, and we end up with a squared minus a minus 6. So our point of contact is actually an algebraic point of contact, where x is a and y is 5a squared minus a minus 6. The next step is very similar to us. So the first step was finding the point of contact. The second point is finding the slope of the tangent. Again, we don't know what the actual x coordinate is, but we're working with x equals a. So we take the derivative, 10x minus 1, and we sub in a, so our slope becomes 10a minus 1. So we've got an algebraic point of contact and we've got an algebraic slope. From here, it's the same process again. We find the equation of the tangent using our standard rule. Very, very carefully we sub in our slope, 10a minus 1. X is part of the rule. X1 is our x coordinate, which is a, plus our y coordinate, which is 5a squared minus a minus 6. We carefully FOIL out the first set of brackets and expand everything. Then we collect our like terms. Now, because we're talking about slope-intercept form, we want it in y equals mx plus c form. So we want this x factorized out, and here it is here. So we've collected our terms that have got x in them. So 10ax and minus x we've factorized to 10a minus 1 times x. From there we've collected everything else. Minus 10a squared plus 5a squared is minus 5a squared. Plus a minus a cancels out and we're left with minus 6. So now you can see that we've actually got an equation for our tangent, but it is an algebraic equation. We need to work out what that point A is. If you have a think about what we've done, we've found an algebraic version of our 2 tangents here. It's a quadratic, so it's very likely to give us 2 answers. We don't know anything about these points of contact yet. We don't know anything about the actual slope of the tangent. What we do know, however, is that this point for -10 is on both of those tangents. So what we do is we sub in that external point. The external point is for -10, and so you can see that we've subbed in y equals -10 and x equals 4. We rearrange and collect everything, And now we've got an equation which is only in terms of a, and what do you know? It's starting to look like a quadratic. In fact, it is a quadratic. So we factorise it, and using null factor law, we establish that a is either 0 or 8. In fact, it is both 0 and 8. So when we find a, we let a equal 0, we sub it in for our tangent to get y equals negative x minus 6. And when a is 8, we sub it in to get y equals 79x minus 326. So we conclude that the two tangents are those, and you can see that in fact these are the two tangents that we've drawn. Whoops. Y equals 79x minus 326 and y equals minus x minus 6. And that's it. That's enough to get you going on exercise 15b.